Okay, we are on question number 6. The reference page that we need would be page 195A. It's in your Algebra 1 Student Edition, Chapter 7. Now, it's going to give you step 1, 2, 3, 4, 5. It's going to lead you through those steps, maybe 6. I forget how many steps. But anyway, we know that the standard form of a line of a quadratic is what? Y equal ax squared plus bx plus c. Y equal ax squared plus bx plus c. So we know that the a of the quadratic is 2, the b of the quadratic is, and the c of the quadratic is 22. Step 1 of building a nice table for a quadratic is to find the line of symmetry. The equation for the line of symmetry is x is equal to the opposite of b over 2a, negative b over 2a. Okay? Now, notice that it's the opposite of what b is, and b was a negative 12. So I'm just going to write it in like that for note's sake, and then 2 times my a of 2. The opposite of a negative 12 is a positive 12. Over 4 is 3. So my line of symmetry, now what kind of a line is the line of symmetry? It's a vertical line. My parabola would open up because a is positive. So my line of symmetry is the line x equal 3. So step 1 is to find the line of symmetry. And then it says to build a table of 7 points. Build a table of 7 points. Now you could do it with 5, but we're going to use 7. We're going to put what y was equal to 2x squared minus 12x. I may ought to make that bigger. Now, it says to make a table of 7 points with the vertex in the middle. I'm going to make this yellow so it kind of stands out. The vertex works kind of like the line of symmetry is going to in the graph, right? So basically what we know right now is this thing, and we're going to, this is the x-axis and that's the y. So here's my origin right here. I'm just going to leave it in red. My line of symmetry is x equal 3. So if we go to the right 3, my line of symmetry would be this vertical line. We're going to just go ahead and plot it. Do you get the idea that if I'm looking at my table, then that little yellow line across there where I'm going to put my vertex symbolically represents the line of symmetry in my graph. It's kind of like if we leaned sideways and looked at that, we could see it, okay? So here's what we're trying to do. We're going to want to pick 3 points on the left side over here because we're trying to get 3 left wing points. So the next thing it says to do is choose 3 points that are less than the vertex x. So we know this. We know that the x of the vertex is the same as the line of symmetry x because the vertex lies on the line of symmetry. Okay? And then what we're trying to do from there is we're trying to choose 3 left wing points, which means we need 3 things that are less than 3, right? To the left of the 3. Well, if we take the first 3 things that's to the left of 3, it would be 2, 1, 0. And so we're going to choose 2, 1, 0. Because that's the first 3 things to the left of my line of symmetry. Okay? We're trying to create 3 left wing points. And now what we're going to do is we're going to plug into my equation to find those 4 values. So we're going to have 2 times 0 squared minus 12 times 0 plus 22. 2 times 1 squared minus 12 times 1 plus 22. 2 times 2 squared minus 12 times 2 plus 22. 2 times 3 squared minus 12 times 3 plus 22. And what we're going to do is find out where the vertex and those 3 left wing points are. Okay? Understand what we're doing? All right. So 0 squared is 0 times 2 is 0 minus 12 times 0 is 0 plus 22 is 22. So I have the point 0, 22. I made a mistake. That's right. 0, 22, which is way up there. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. We just got that left wing point. And then we're going to have 1 squared is 1 times 2 is 2. 2 minus 12 is negative 10. Negative 10 plus 22 is 12. So my second point is 112. To the right, 1 up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We just got a second left wing point. And then 2 squared is 4 times 2 is 8. Minus 24 is negative 16. Plus 22 is 8. 6. That's right. 6. So we have 2, 6, which is to the right 2 up 1, 2, 3, 4, 5, 6. My vertex 3 squared is 9 times 2 is 18. 18 minus 36 is negative 16. Negative 18. Negative 18 plus 22 is 4. So my vertex is at 3. 1, 2, 3, 4. Notice the vertex is on the line of symmetry. We knew it would have to be, right? So the vertex is 3, 4. What we just did is we found the vertex and 3 left wing points. So we got the left side of our parabola. Now, we're not just putting this in Weichel in the calculator and taking any 6 things that pop up. We're specifically doing this in a way that if the line of symmetry was something like negative 1/5, we would still know what to do, okay? Now, what we would do then is we know that if there's a point here, it's going to have a sister point over here. And if there's a point here, a sister point over here. And if there's a point here, it's going to have a sister point over here. Those reflecting points. We want to find those reflecting points. Now, what that tells me then is if there's a 6 right here, there's going to be another one on the other side. Are we visually seeing how we're making the table and graph connect? If there's a 6 here, there's going to be a 6 there. If there's a 12 here, there's going to be a 12 here. If there's a 22, there's going to be a 22 here. We're going to reflect the upper 3 y's across the imaginary line of symmetry, across our vertex, and figure out our bottom y's. Now, to get the top ones, here's what we're going to think. We would say, if we were looking at this visually, how far from the line of symmetry is that, and we'd have to go that much the other way. How far from the line of symmetry are we here? We go that far this way. How far from the line of symmetry are we? We go that far that way. Well, saying how far we are from the line of symmetry is no different than saying how far are we from the vertex. So watch how we do that in the table. Is everybody watching? Some of you are working ahead and not watching. Wait till you get to the test and it's negative 1/5. You'll wish you had watched. Whoever's watching this video Watch it. Don't go to sleep and daydream. Anyway, here we go. So we're going to say how far from the vertex is that 2. Well, how do you go from 3 to 2? Minus 1. So that's kind of like this. We went, see in the graph, we went left 1. What's the opposite of left 1? Right 1. Well, the opposite of down 1 is up 1. So we can realize what we're doing by saying the opposite of down 1 is up 1. 3 plus 1 is 4. Let's look at the next one. From 2 to 1 is down 1. What's the opposite of down 1? Up 1. Up 1 from 4 is 5. That's another down 1. The opposite of another down 1 is another up 1. So we get a 622. Notice we did nothing in the middle of the table at the bottom. We got those bottom points by reflecting the top ones across the line of symmetry. We did that visually in the graph by looking. We did it mathematically in the table by thinking how far down I'm going to go the opposite. Everybody see how we got nice, pretty parabola points? And so if we plot those, we would have 4, 6 to the right. 1, 2, 3, 4, up 6, and we're here. And then we would have 5, 12 to the right, 5 up 12, which would put us here. And then we've got 6, 22 to the right, 6 and up 20 here. And then we get the right wing, which matches up nicely with the left wing, and we get a pretty little parabola. Everybody see how we used the rules and the words on page 195A to build a pretty little table that would create a pretty little parabola. All right, that's the end of lesson 12.